In number 12, I want to know if these two are functions of one another, or inverse functions of one another. And I'm going to use the composition test. And the composition test basically says this. I do the composition twice. I do the f of g of x. So I plug one function into the other. And then I do g of f of x. I plug it in reverse. Okay? And really, the composition test says if these two things are inverses, then I'll get an x each time when I do this composition. So over here, when I plug an x into the g function, it gives me the 2x minus 4. And so now I'm plugging that value into my f function. So I plug the 2x minus 4 into my f function. And now I just simplify to see what I get. Here I distribute. That gives me an x minus 2. And then I combine like terms, so I'm left with just an x. And it's not enough to just do this composition. I have to check the other one also. So I do g of f of x. If I plug an x into the f function, that's a 1/2 x plus 2. And now I'm going to plug that whole thing into my g function. So I plug the 1/2 x plus 2 in. And now I simplify. I want to see if I end up with an x again, so I distribute. That gives me an x plus 4. I combine like terms, and I get an x. So since I got an x for the first composition and an x for the second composition, it means that, yes, these two things are inverses. Okay, so these two functions are inverses because they pass the composition test. Here we want to graph the inverse of this thing, and there's a couple things we need to consider here. The first thing we're going to do is actually find the inverse. So again, think of this as y equals 2 square root of x. So I switch the x and the y, and now I'm going to solve this for y. So to solve this for y, I divide each side by 2. So really that's a 1/2 x equals the square root of y. And now I square each side. So I end up with a 1/4 x squared equals y. So in other words, my inverse in function notation is a 1/4 x squared. And I know how to graph a 1/4 x squared. A 1/4 x squared is a parabola, and it's a parabola that's going to look like this. It's a wide parabola because it's being stretched vertically. It looks something like this. And of course, each of these values would be reflected. But now this isn't quite right because I have to think of this in terms of the inverse. And remember, the inverse is always going to be reflected around this line. And so when I think about the graph of the original function, the 2 root x, it's essentially going to be a sideways parabola that looks kind of like this. We've got a point here, we have a point here, here, and work my way this way. And it would be the same thing going in the other direction. However, when we take a closer look at this thing, this sideways parabola that I have graphed in red, that's the positive and negative version. And if we look at my original function, that just has a positive 2 out front, which means I only want the positive version, which means my original function is just the top half of the thing that was graphed in red, which means my inverse can't be that entire parabola. It's only the piece that's reflecting the red function, and the piece that's reflecting the red function is this piece over here, which means I've got to get rid of this guy. Okay? So essentially I'm going to erase that, which means I only have half of a parabola for my inverse, which means my true inverse was this function with the restriction that x is greater than or equal to 0. Okay? In other words, we're only graphing half of this parabola because that's the piece that reflects the f of x function, which means the graph of my inverse is just the thing that I have in blue. So I can get rid of everything else. I was just using everything else as a frame of reference to determine if I was graphing the entire parabola or if I was only graphing a piece. Okay? And in this case, I only graph a piece because I only have the top half of that square root function. I'm only going to have the positive half of my parabola. Okay? In this one, I'm just graphing the square root function. Remember, my typical square root function looks like this. It follows a very similar pattern to my parabola. It's a sideways parabola. But this one, because I have a negative inside with the x, it's just going to open in the other direction. So it's going to open to the left instead of the right. So it looks like this instead. Okay? For this one, again, I think about that same pattern, all right, that same sideways parabola that I would have had before. That's the original, that's the square root of x. But this is going to be shifted to the left 1 and down 2. Remember, inside with the x, it always does the opposite of what we might think. So I go to the left 1, which would bring me to here, and then I go down 2, which brings me to here. So that's essentially my new vertex. And now I follow the same pattern as I did before. So I get a parabola that looks like this. It's the same parabola, only it's been moved to the left 1 and down 2. Okay? The next one, or the last one rather, I'm doing the same thing here. If I look inside here, I'm going to move this to the right 1 and up 3. So my new vertex to the right 1 and up 3 is going to be right here. And then I have to look at what's on the outside here. This 2 means it's going to open up, and it's going to be stretched vertically, which means instead of going to this point right here, I'm going to double that height and put it here instead. Instead of going to the next point right here, I'm going to double that height and go up here. The next one, sorry, that went a little too high. Should be up here. The next one, instead of having a value that's right here, I'm going to double it and put it up here, and so on and so forth. So I'm basically doubling all these heights, so I get something that looks like a wider sideways parabola because it's been stretched vertically. Okay? Hope this was helpful. Good luck on your test.